So we're going to look a little bit at using partial fractions to help us with integration problems. So you should really already know what partial fractions are and how we get partial fraction forms, but we'll sort of be reminded a little bit of how to do that throughout the lesson. And then we're going to use partial fractions then to integrate certain quotients, certain fractions, by converting them first into partial fractions and then integrating with them. So let's take a look at that. The first thing I want to do then is to just remind ourselves of what the various partial fraction forms are. Let's take a look at that. So probably the easiest thing is to just go through a couple of examples. Let's say we've got something like this. We've got 1 over x minus 1 times x minus 2. Okay, we should be comfortable with the idea that that can definitely be expressed in a form that looks like this. Okay. If alternatively I had something that looked like this, let's say it was x minus 1 times x minus 1. Okay, what it won't be is this. Okay, whenever the denominator has this sort of repeated expression, so you might just see it as x minus 1 squared, you're not going to write it in this specific form. You're going to have to incrementally increase the power. So you're going to have a over x minus 1 plus b over x minus 1 squared. Okay, and then to just really sort of drill this in, let's give let's do something like this. Let's say I've got x minus 1 squared x minus 2 cubed, say. So let's take it to a bit of an extreme. You wouldn't really get something like this, but let's say you did. Then that's going to be a over x minus 1 plus b over x minus 1 squared plus c over x minus 2 plus d over x minus 2 squared plus e over x minus 2 cubed. Okay, so you can probably see why I said that probably wouldn't come up. There's quite a lot of unknowns there, although you could still do it. So the point being that the number of individual fractions you're going to end up with is the same as the number of things you're multiplying in the denominator. So in the first two examples you've got two things going on, so you've got two fractions, and here you've got a squared and a cubed, so that's 5 things going on there being multiplied, and because you're multiplying 5 things, you've got your 5 partial fractions. And again, if it's repeated, you're just going to have to incrementally increase the powers for each of those denominators, although most of the time it's not going to be more than a squared really. Okay, so that's just to remind you of the partial fraction forms. So now let's look at a few examples. I think I've got about 3 examples that I want to just quickly knock through. So the first thing you're going to need to do if you're doing integration by partial fractions is find the partial fraction. So let's do that. So we've got this can definitely be written in this form. Okay, then multiply both sides by x plus 1, x minus 2, and we get the following. Let's substitute in some reasonable values for x. So remember, this is technically an identity, isn't it? We're saying this is always the same, so it doesn't matter what the value of x is. So let's try x equals 2, x minus 1. So when x equals 2, that implies and when x equals minus 1, that implies the following, and altogether we then get b equals minus 1 and a is equal to 2. So then next, we're going to just rewrite this integral. So that's the integral of 2 all over x plus 1, that's the a, minus 1 all over x minus 2, and that's me inserting the b. And then we can use integration methods that we already know about to get the solution to this. So left-hand side, or I should say the first partial fraction out of the two, the first one, the derivative of the bottom is 1, the top is 2, which is just double. So therefore we can write that integral as just being 2 ln mod of x plus 1. And then the second integral, the bottom of the partial fraction is x minus 2. The derivative of x minus 2 is 1. That's the same as the top, so we can straight away directly write that as ln of x minus 2. And is minus because we are in fact minusing those two partial fractions, so that minus there becomes that minus there. And then to just finish that off, we can combine all this, right? So we can say that's ln of x plus 1 squared, and I can forget the modulus now because if I'm squaring something it doesn't actually matter, minus ln of x minus 2, and that's therefore then equal to ln of, and now I do need to use the modulus actually because I'm combining the two, x plus 1 squared all over x minus 2. Okay, and we've written it as a single log, okay, plus c, and that's our answer. So then let's look at this one. I'm not going to go through the whole process of finding the partial fractions, but let's just set up what the form would look like. So we know this can definitely be written in the form a over 2x plus 1 plus b over x minus 2 plus c over x minus 2 squared. Okay, I can leave it to you then to check if you can figure out what the a, b and c are. If you're completely comfortable with this, you know exactly how to do it, that's fine. If you do want to just briefly practice, just pause the video now, and in a moment I'll put the actual values. So if you do want to quickly try it, pause the video now. Okay, and the values you should have gotten are 2 for the 2x plus 1 part, minus 1 for the x minus 2 squared part, and plus 3 here for the x minus 2 part. So now let's see how we find the integral of this. Technically I should have written the integral sign around the whole thing here. Okay, let's take a look. So first one, very easy. The integral of the bottom is 2. That's the same as the top. So it's ln mod of the bottom, 2x plus 1. Okay, let's look at this one. Again, integral of the bottom is 1. X minus 2, sorry, derivative of the bottom is 1. So the derivative of x minus 2 is 1. The top is 3, so therefore I need to multiply by 3 times ln of the bottom. And the third one, we can't use our ln trick, but we can do some sort of form of reverse chain rule, I suppose. So let's just on the side here make a little note. Okay, so I want to find the integral of, let's just take the positive version, 1 over x minus 2 squared. Okay, we remember that that's the same thing as the integral of x minus 2 to the minus 2 dx. So then let's try finding the derivative of x minus 2 to the power of minus 1. So by chain rule, that will be minus x minus 2 to the power of minus 2 times the derivative of the inside, and the derivative of the inside is 1. So if I'm multiplying this whole thing by 1, then it doesn't change. And therefore we've got it then. So almost, because this answer is just the negative of that one. So then in fact, because we have the negative version here, we can say the integral of this whole thing, the negative one, is just going to be x minus 2 to the minus 1. Okay, that should be something we're comfortable with really, but it's good to just remind ourselves sometimes of how these things work. So you've got x minus 2 all to the power of minus 1. And then we just need to do the final combining of the logarithms. So that's equal to ln of 2x plus 1, 2x plus 1 plus ln of x minus 2 cubed plus, and let's just rewrite this as 1 over x minus 2 rather than having minus 1 power. And that's equal to, if we're adding logs, we're multiplying, so that's the ln of 2x plus 1 times x minus 2 cubed plus 1 over x minus 2. And that we can't really combine with the logarithm, that's just stuck there. Plus c. Okay, and that's the answer to that particular integral. Okay, and then final one in this section of these types of partial fraction integrals. Hopefully in this case you can see quite quickly, and you have to be able to recognise this, the bottom is difference of two squares, isn't it? 1 is in fact a square number. So we've got the integral of 2 all over 1 minus x times 1 plus x. Okay. So let's take a shortcut now and just put what this would be. But again, with partial fractions, you should be able to find out what that is. In this case, we're going to get the integral of 1 all over 1 plus x and 1 all over 1 minus x. And again, if you're not quite comfortable with that, you just need to review how to do partial fractions. So once we've got that, first one, ln of 1 plus x. Second one, so the derivative of the bottom is minus 1, but at the top I've got 1, therefore I have to multiply by minus 1. So it'll be minus 1 times ln of the bottom. There we go. And then taking away 2 logs, and we end up with this, which is quite nice looking actually. Plus c. Okay, and then the one last example, which is now a different kind of problem, but it's very similar. It's just got a different or an extra first step. Is when you have the situation where the degree of the polynomial on the top is the same or more than the degree of the polynomial on the bottom. So the degree of the polynomial on the bottom is 2, because the highest power of x is 2. The degree of the polynomial on the top here is also 2, because the highest power is 2. So if the degree of this top part were 2, 3 or 4, that's greater than or equal to the 2 here, so therefore we're going to have to do something slightly different. If you look at the previous examples, yeah, this is degree, in this case 0, because it's a constant, degree 2. This one's degree 2. The bottom here, that's degree 3, isn't it? If you multiply that out, you look at your powers of x, you'll have degree 3, right? This one here, that's degree 1, and the bottom here is degree 2. Okay, so in every example we looked at so far, the degree of the top was less than, strictly less than, the one on the bottom. In this case, they're equal, so we're going to have to do something slightly different. You may know what it is already. We're going to have to divide the top by the bottom algebraically. So let's just do that. Now, I find people tend to have different methods of doing this, but I'll just quickly do it the way I tend to do it. So the thing I'm dividing by, and then I want to be careful here actually. Let's make sure we include all the powers. So I've got here 0x. Oh no, what am I talking about? That's fine. Yeah, let's go back. No, that was fine. And then I'm going to divide by 9x squared minus 4. In this case, 1 on the top. So I've got 9x squared minus 4 find the difference. The first line minus the bottom line, I end up with 0 minus 3x, and then the 2 minus the minus 4 gives me plus 6. Okay, so what that then tells me is that this thing, the original integral, oh, let's just move this down here. This original integral, it's 1 plus, and then my remainder, which was minus 3x plus 6, let's rewrite that as 6 minus 3x, all over what I originally divided by. Okay, so just a refresher of algebraic division there. Okay, we've rewritten it, and then you can probably see what to do. We should be fine now. The integral of 1 is going to end up being x, and the integral of this thing, well, that's going to be using partial fractions again. If I just started off again, and you need to be able to spot this, what you notice about the bottom of this fraction at the moment, difference of two squares, right? 9x squared, that's 3x squared. 4 is 2 squared, so therefore I can straight away rewrite it as this. Okay. And now I'm just going to skip a step. I'm not going to go through the working of finding out this partial fraction here. I'm just going to write it out. And it's 1 plus 1 all over 3x minus 2 minus 2 all over 3x plus 2. And we now do our usual integration. Integral of 1 is x. Integral of 1 over 3x minus 2, that's 3 ln 3x minus 2. Then we're going to do minus, and in this case the integral of the bottom is 3, but I want 2, so to turn the 3 into a 2 I'm going to multiply by 2/3. And we've got the ln of the bottom plus c. And, oh, I've made a mistake here, haven't I? That 3, integral of the bottom here is 3, but I want 1, so I need to multiply by 1/3. Trip myself up there. There we go. So let's put that all together. That's equal to x plus, and in this case I'm actually going to take 1/3 out and then rewrite it this way. And if I take 1/3 out of this part, I'm just going to be left with 2. And then I can take that 2 and put it on the power of the log of the ln. So let's change it that way. And I'm just running out of space there. So let me just remove some working. Okay, let's put this up here. Let's stick in my precious plus c. And let's finish this off. So we've got 1/3 of ln, and in this case 3x minus 2 all over, because we've got a negative of the, because we've got a minus sign here, so I'm doing all over, 3x plus 2 squared plus c. Okay, so I think that's enough examples now. Hopefully you've got the idea. Let's take a look at a few questions. I think I've got 3 questions lined up. So have an attempt at this question first. In this case, for part C, you're going to have to also, do a definite integral, but that should come quite easily. You know how to do integral of partial fractions now. So give this question a go. Pause the video now. Okay, and if you finish that question, let's take a look at the answer. There you go. And then let's take a look at the next question to try. So if you want to try this question, pause the video now. And the answer to this is here. And let's look at our final question. Have a go of this one. And your answer is here.